This video will go over basic input and output using the NodeMCU's GPIO pins. If you wish to follow along with this guide, you will need 4 jumper wires, one 6mm push button, one 5mm LED, one breadboard, one microUSB cable, an ESP8266 NodeMCU, one resistor with a value in the range of 1 kiloohm to 10 kiloohms, and one resistor in the range of 46 ohms to 100 ohms. Start by carefully lining up your NodeMCU so that it is centered at the end of the breadboard. There should be a single line of holes on either side of the NodeMCU. Once it is centered, carefully press it into the board so that the black plastic at the top of the pin is touching the breadboard. Connect a jumper wire from a pin labeled GND on the NodeMCU to one of the rails on the outside edge of the breadboard. This rail is now your ground rail. For those of you following along with the guide on our website, you will notice that I use a different rail in the image. In both cases, I use the rail labeled with a minus sign. As long as you keep your rail use consistent, it doesn't matter which you use. Take your LED and connect the long lead, the anode, into the pin labeled D1 or GPIO 5. Then connect the short lead, the cathode, to an empty breadboard row. Next, take your lower valued resistor and put one of its leads in the same row as the LED's cathode and one lead in the ground rail. On your computer, open Thonny and connect the NodeMCU with a microUSB cable. Press the stop button to get a REPL. If you have issues getting the REPL to appear, make sure that your interpreter and port are set correctly. Enter the following code into the editor. You can also copy it from our guide or gist links located in the description of this video. This code will blink the LED that you connected to GPIO 5 10 times. Click File, Save As, and choose MicroPython device. Name the file main.py and click OK to save the program to your NodeMCU. Press the reset button, labeled as RST, on your NodeMCU. Your program should start and you will see your LED blink 10 times. Before moving on, make sure that you unplug your NodeMCU. It is good practice to power down your circuits when modifying them. Leave everything else on the breadboard as is. Take a look at your 6mm push button. You'll notice the 4 leads have a flat side and a narrow side. The pairs of leads with the flat side facing each other are both connected to the same side of the button. Connect this button at the end of the breadboard, bridging the gap between the two sides. Create a 3.3 volt rail by connecting any of the pins on the NodeMCU labeled 3v3 with the empty rail next to your ground rail. Remember, the rail in the written guide's images won't exactly line up. Connect one side of the button to the pin labeled D2, GPIO 4, and the other side of the button to your ground rail. Go back to Thonny, plug your NodeMCU into your computer, and acquire a REPL. Change your program to check for the value of the button. Again, code can be copied from our guide or gist links in the video's description. Press the restart button to run the new program. The button value is continuously being printed in Thonny's shell tab. If you press the button, you will notice that the value isn't changing in an expected way. The expected behavior is for the button's value to be a 1 when not pressed and a 0 when pressed. We are not observing this because the circuit is missing a critical component, a pull-up resistor. This causes the pin to be floating, meaning the value is somewhere between 0 and 3.3 volts at any time. Luckily, this is easy to implement. Unplug your NodeMCU and connect your higher value resistor to D2, GPIO 4, and the 3.3 volt rail. Adding this pull-up resistor connects the pin to 3.3 volts when the button is not pressed, giving it a high value. When the button is pressed, the pin is connected directly to the ground rail, giving the pin a low value. Plug the NodeMCU into your computer again and acquire REPL and Thonny. Then press the reset button on the NodeMCU to start the same program as before. You should see that the values printed in the shell tab are what is expected. The pull-up resistor fixed the problem. There is another way to implement a pull-up resistor. The ESP8266 microcontroller contains pull-up resistors that can be enabled in your program. Remove the external pull-up resistor from the breadboard. It is redundant if the internal one is enabled. Then add the optional pull-up resistor parameter to the pin initialization line in your code. Save the new main.py program to your NodeMCU and press the reset button. You should see that the program behaves just as it did previously. Using what you have learned, I encourage you to try writing a program on your own that turns on the LED when the button is pressed. Leave the physical components on the breadboard as is while you do this. A solution can be found at the bottom of the guide linked in the description of this video. Good luck!